Imagine a house that pretty much takes care of itself. It heats and cools itself, it gives you your own water, your own electricity, and it's built out of junk. It's this incredible dream, right? A home that takes care of you and the planet. That is the promise of the Earthship. But the big question is, does that dream actually work when you take it out of the desert and drop it into different climates around the world?
And I mean, just look at them. They are so unique. They're usually built right into a hillside. You've got this long wall of glass facing the sun, and the other walls are made from old tires just packed with earth. Seriously, they look like they've grown right out of the ground. They promise this totally self-sufficient, off-the-grid life. So what is an Earthship, really? Well, according to the guy who invented them, architect Michael Reynolds, it's basically a self-contained living machine. It's supposed to make its own electricity with solar panels, collect all its water from the rain, and, this is the big one, stay at a comfortable temperature all year round, with no furnace and no air conditioning. So in this explainer, we are putting that dream to the ultimate test. First, we're going to run a reality check across 4 totally different climates. Then, we'll dive deep into comfort and self-sufficiency, run the numbers on the financial bottom line, and then we'll deliver the final verdict. Okay, so how do you even test a dream like this? Well, we're digging into a scientific study that did just that. They used these super detailed computer models to see how an Earthship actually performs out in the real world. To find out if this is some kind of one-size-fits-all solution, the researchers simulated its performance in 4 radically different places. We're talking the freezing subarctic of Anchorage, Alaska, the humid 4-season climate of Grand Rapids, Michigan, the dry heat of Albuquerque, New Mexico, and, of course, the tropical weather of Honolulu, Hawaii. And here's the key to making this a fair fight. They used the exact same 3-bedroom Earthship design in every single city. That's so important because it lets us see exactly how the architecture itself holds up when the environment around it completely changes. All right, let's get to the good stuff, the results. We're going to look at those 3 core promises: thermal comfort, water, and electricity. So does the Earthship actually deliver on what it says it's going to do? Okay, now this is the secret sauce. This diagram shows you the engineering heart of the Earthship. See, the sun shines through that big glass front, and it heats up this massive wall of tires packed with dirt. This thermal mass acts like a giant, slow-release battery for heat. It just soaks up the sun's energy all day and then slowly radiates it back into the house all night long. So this all leads to the big question, right? Does this incredibly clever design actually work? Can it keep the house comfortable? Somewhere in that sweet spot between 21 and 28 Celsius or 70 and 82 Fahrenheit, all by itself? Well, the simulation results are pretty eye-opening. In the freezing winters of Anchorage and Grand Rapids, the house gets uncomfortably cold without some kind of backup heat. No way around it. In Albuquerque, it does pretty well, but you still get these big temperature swings. It's only in the super mild climate of Honolulu that it actually stays comfortable all year. So that dream of a house that needs no furnace, it kind of hits a hard wall of winter reality. But, and this is a big but, here's the other side of the coin. While it might not be perfectly comfortable on its own, this chart shows the design's greatest strength. In those cold climates, the Earthship's design crushes it, dramatically cutting down how much heating you need compared to a standard home. We're talking huge savings. Of course, in a place like Honolulu where you don't have a heating bill, there's no advantage. Okay, let's switch gears to promise number 2, water. And this right here is where the Earthship design is an undisputed champion. I mean, look at this. By catching rainwater and then recycling the gray water from your showers and sinks to do things like flush toilets, it slashes water use for a family of 4 down to just 370 liters a day. That's almost 80% less than the US national average. It's incredible. But here's the catch. There's always a catch, right? Even with that amazing efficiency, can the roof actually collect enough rain to keep up? Well, the data shows that only in a really wet climate like Grand Rapids does the supply actually beat the demand. In Anchorage, and especially in dry Albuquerque, there just isn't enough rain falling from the sky to keep those water tanks full. And that's a huge deal because, as the study itself points out, for a house to be practical, you need a consistent supply of water, period. This means that for most places, being totally self-sufficient for water just isn't realistic. You're going to need a backup connection to the city water or a well. It's not an option, it's a necessity. All right, last promise, electricity. What does it actually cost to go 100% off-grid? You might want to sit down for this. The numbers are just eye-watering. To get through those long, dark Alaskan winters, the solar panel and battery system you'd need would cost over $105,000, and that's in 2006 money. Even in the sunniest spots, you're still looking at tens of thousands of dollars.
So this leads us to the final question, and for a lot of us, it's the most important one. When you put all the performance stuff aside, does building an Earthship actually make financial sense in the long run?
And this is where things get really, really interesting. If you forget about that super expensive off-grid solar system and just connect your Earthship to the grid, the answer in cold climates is a definite yes. Yeah, it costs more to build upfront than a standard home, but the massive savings on your heating bill pay back that extra investment in just 8 years in both Anchorage and Grand Rapids. But it's a totally different story in warmer climates. In Albuquerque, it takes a lot longer to break even, about 11 years. And down in tropical Honolulu, with no heating bills to save money on, the more expensive Earthship actually never pays for itself. And as for that original, pure, off-grid dream, the study's conclusion is pretty blunt. When you add in the crazy cost of the solar panels and batteries you need to be fully energy independent, Earthships are just not a financially competitive alternative to a regular home that's hooked up to the grid. So let's pull all this data together and land the plane. What's the final verdict? What is the reality of the Earthship once you separate it from the dream? Well, here's the balanced scorecard. The strengths are absolutely undeniable. Huge energy savings in cold places, mind-blowing water efficiency, and the fact that it's built with recycled materials. But the weaknesses are just as real. They need backup heat to be comfortable in the cold. You can't rely on rainwater alone in most climates. Going fully off-grid is just way too expensive, and the whole design doesn't make much financial sense in the tropics. And this leads us to what might be the study's most important takeaway: the pure, 100% off-grid Earthship concept. It may not be practical for most people in most places, but its ideas, the thermal mass, the passive solar design, the water recycling, those can absolutely be used, even if you have a grid connection, to make all of our homes way, way more sustainable. Which leaves us with one last big question to think about. This data really suggests that the dream of a single, perfect, sustainable house that works everywhere, that might be a fantasy. Maybe the future of sustainable building isn't a universal blueprint at all, but a design that is smartly and uniquely adapted to the specific weather, challenges, and advantages of its own local climate. What do you think?